Hi, this is Srikanth as Assistant Professor of EEE Department. In this session, I'm going to discuss the question bank problems on Module 4, Bipolar Junction Transistors. The first problem, in a common base connection, the emitter current is 1 milliampere. If the emitter circuit is open, the collector current is 50 amperes. 50 microamperes. If the emitter is open, the collector current is 50 microamperes. Find the total collector current given that alpha value is equals to 0.92. Here the given data is alpha value is equals to 0.92. Emitter current is 1 milliamperes. Here emitter circuit is open. The collector current is nothing but that is a leakage current, that is ICB0, which is equals to 50 microamperes. And we need to calculate what is the value of collector current. Here the collector current is equals to alpha into IE plus ICB0. Here this is the formula for calculating the collector current, that is alpha into IE plus ICB0. Here if we substitute these values into the equation, IC is equals to 0.92 into, where IE value is 1 milliampere, 1 into 10 to the power of minus 3 plus 50 into 10 to the power of minus 6. So IC value is equals to 0.97 milliamperes. This is the total collector current which is corresponding to the given common base transistor circuit. Now the second problem, find the values of beta and gamma if alpha value is 0.9 or alpha value is 0.98 and alpha value is 0.99. Here the relation between the alpha, beta, gamma. Alpha, if we know, beta is equals to alpha by 1 minus alpha. If we know the beta value, gamma is equals to 1 plus beta. This is the relationship between the alpha, beta, gamma. And if we know beta, alpha is equals to beta by 1 plus beta. This is the relationship between alpha and gamma, between alpha, beta and gamma. So here the alpha value is given, we need to calculate the beta and gamma values. Here alpha value is given as the first value, which is given as 0.9, that is equals to beta is equals to alpha by 1 minus alpha, which is equals to 0.9 divided by 1 minus 0.9, that will give 0.1. 0.1, 0.9, 0.9 divided by 0.1 will gives us 9. This is the beta value. And gamma is equals to 1 plus beta, that is 1 plus 9, which is equals to 10. These are all the ratios. So there is no units for alpha, beta and gamma. If alpha, the second case for alpha is equals to 0.98, beta is equals to alpha by 1 minus alpha, which is equals to 0.98 by 1 minus 0.98, that is equals to 0.98 by 0.02, which gives us the value as 49. So here the gamma value is equals to 1 plus beta, which is equals to 1 plus 49, which is 50. And for alpha is equals to 0.99 and beta value is equals to alpha by 1 minus alpha, that is 0.99 by 1 minus 0.99, which is equals to 0.99 divided by 0.01, which gives us the 99 as the beta value, and where the gamma value is equals to 1 plus beta, which is equals to 1 plus 99, which is 100. Now the next problem is, in a transistor given the base current IB as 240 microamperes and IE as 12 milliamperes and beta is equals to 49. Find the alpha rating of the transistor and hence determine the value of IC collector current using both gamma and alpha rating of the transistor. So here the given data is base current is 240 microamperes and emitter current is 12 milliamperes and beta is equals to 49. So here alpha is equals to, when we know the beta, alpha is equals to beta by 1 plus beta, which is equals to 49 divided by 1 plus 49, which is equals to 0.98. And where IC value collector current is equals to alpha into IE if we neglect the leakage current. If we neglect the leakage current, IC value is equals to alpha into IE, that is equals to 0.98 into 12 into 10 to the power of minus 3, which is equals to 11.76 milliamperes. Now IC is equals to, we can also write the equation as beta into IB, that is equals to 49 into 240 into 10 to the power of minus 6, which is equals to 11.76 milliamperes. And it is also asked to calculate by using the gamma. The gamma value is 1 plus beta, that is 1 plus 49, which is equals to 50. This is the gamma value, and this is the way we are going to calculate the collector current when we know alpha, beta and gamma values. Now in a common base connection, the emitter current is 6.28 milliamperes and the collector current is 6.20 milliamperes. Estimate alpha, beta and gamma. Here IC and IE values are given, and that is nothing but there is no leakage current. Here we are assuming that there is no leakage current because it is not mentioned the leakage current is available. So we can go with the calculation of alpha, beta and gamma. So here IE value as 6.28 milliamperes and IC value as 6.20 milliamperes. Here alpha is equals to IC by IE. This is from the formula IC is equals to alpha into IE plus ICB naught. Here this value is 0. When this value is 0, alpha is equals to IC by IE. So when alpha is equals to IC by IE, now we are substituting the values of IC and IE here. Here IC value is 6.2 milliamperes divided by 6.20 0.28 milliamperes, which is approximately equals to 0.9873. And beta is equals to, when we got the alpha value, we can easily calculate from the relation between the alpha, beta and gamma. So first let us calculate the beta value, that is where beta value is equals to alpha by 1 minus alpha, which is equals to 0.9873 by 1 minus 0.9873, which will gives us the value as 77.74. Now we got the beta value as 77.74, and the gamma value is equals to 1 plus beta, that is 77.74 plus 1, which is equals to 78.74. The next one is, a transistor has alpha is equals to 0.975. What is the value of beta and gamma? If beta is equals to 200, what is the value of alpha and gamma? So here the two different cases are given. The alpha value given and beta values are given, and the remaining uh, parameters which we need to calculate. So here first let us consider our first case when the alpha value is given. Here the alpha value is nothing but it is the ratio of IC by IE. So when the alpha value is given as 0.975, here the alpha value is given as 0.975. Now for calculating beta, where beta is equals to alpha by 1 minus alpha, which is equals to 0.975 by 1 minus 0.975, which is equals to 39. This is our beta value, and where gamma is equals to 1 plus beta, which is equals to 1 plus 39, which is 40. Now for beta is equals to 200, for beta is equals to 200, where alpha is equals to beta by 1 plus beta, which is equals to 200 by 1 plus 200, which will gives us the value as 0.995, which is nearly unity. And this value is the alpha which we got for when beta value is 200. Now the gamma value is equals to 1 plus beta, which is equals to 1 plus 200, which is equals to 201. This is the gamma value which we got for the given beta value. Now the next problem, a transistor is operating in common base configuration, has a DC current gain of transistor is 0.967, and if the emitter current is 10 milliamperes, what is the value of base current and beta? Here the configuration which is given as common base configuration, and here the DC current gain is nothing but it is the ratio of collector current to the emitter current, and that is nothing but our alpha value, where alpha value is given as 0.967 and the emitter current is given as 10 milliamperes. Emitter current is given as 10 milliamperes. We need to calculate the base current. Here, in order to calculate the base current, we need to calculate the collector current. When we know the collector current, then only we can able to calculate the base current. We don't have direct relation with the emitter current to the base current. So first let us calculate the collector current. So the collector current IC, here the given data is alpha is equals to 0.967 and IE is equals to 10 milliamperes. And collector current IC is equals to alpha into IE plus IC B naught. Here this leakage current we are assuming it as 0 because it is not mentioned in the problem. So we are assuming this IC B naught value as 0. So IC is equals to alpha into IE. IC is equals to alpha into IE, which is equals to 0.967 into IE value is 10 milliamperes. 10 into 10 power minus 3, which is equals to 9.67 milliamperes. This is the collector current we got. This is not the current which we need to calculate in the problem. In the problem, the given current to calculate is the base current. So IE is equals to IC plus IB, where IB is equals to IE minus IC. That is equals to 10 minus 9.67, which is equals to 0.33 milliamperes. So IB is equals to IE minus IC, 10 minus 9.67, which is equals to 0.33 milliamperes. Now the IB is equals to 330 microamperes. Now the base current will be 330 microamperes. Always the emitter and collector current will be in milliamperes because these currents are having the high value, whereas the base current will be always in microamperes because a small amount of current will be there in the base, because the base is lightly doped and emitter is heavily doped and collector is moderately doped. So collector and emitter will be having the currents in the milliamperes, whereas the base current will be in the microamperes. Now a transistor has IB has 105 microamperes and IC has 2.05 milliamperes. Find beta of the transistor, alpha of the transistor, emitter current, gamma of the transistor. Here given that IB is equals to 105 microamperes and IC is equals to 2.05 milliamperes. Now only IB and IC values are given. Now we need to calculate the beta, alpha, IE and gamma. So in order to calculate the beta, IC is equals to beta into IB plus IC B naught. Sorry. Here the IC is equals to beta into IB, where beta is equals to, it is the ratio of collector current to the base current, which is equals to 2.05 into 10 to the power of minus 3 divided by 105 into 10 to the power of minus 6, which is equals to 19.523. This is the beta value. When we know the beta value, how we can calculate the alpha, where alpha is equals to beta by 1 plus beta. So beta is equals to 19.523 divided by 19.523 plus 1, which is equals to 0.951. And here the IE is equals to IC plus IB, where IC is equals to 105 into 10 to the power of minus 6 plus 2.05 into 10 to the power of minus 3. Here this 10 to the power of minus 6 can be written with 10 to the power of minus 3 with 0.105 with 0.105. If we add 0.105 to this 2.05, this will become 2.155. That is 2.155 milliamperes. Now gamma is equals to 1 plus beta, which is equals to 1 plus 19.523, which is equals to 20.523. Now, in a common base transistor, amplifier has input resistance of 20 ohms and output resistance of 100 kilo ohms. The collector load is 1 kilo ohm. If the signal is 50 millivolts applied between emitter and base, find the voltage amplification factor. Assume alpha to be nearly 1. Here, this is the input which we have given. This is the emitter, base, collector with PNP layers with P N P. Here the emitter is P layer and base is N layer, collector is P layer. And here this is the input signal which we are giving, that is 500 millivolts. And the input resistance is 20 ohms and the output resistance is 100 kilo ohms. And RC value is given as 1 kilo ohms. So here the given data is R input is equals to 20 ohms, R output is equals to 100 kilo ohms, RC is equals to 1 kilo ohms. Now the input current IE is equals to input voltage by input resistance. That is signal voltage by input resistance, that is 500 millivolts by 20, which is equals to 25 milliamperes. And here alpha value is nearly 1. IC is equals to IE, which is equals to 25 milliamperes. Now output voltage V output is equals to output current into output resistance. Here the output current is the collector current into collector resistance. Here 25 into 10 to the power of minus 3 into 1 into 10 to the power of 3, which is equals to 25 volts. Now the voltage amplification factor AV is equals to V output by V signal, which is equals to 25 by 500 millivolts, which is equals to 50 is the voltage amplification factor. Now the next problem is for a certain transistor IB is equals to 20 microamperes, IC is equals to 2 milliamperes and beta is equals to 80, and we need to calculate what is the ICB naught. So here the given data is the base current is given 20 microamperes. As we have discussed, always the base current will be in microamperes. and collector current is 2 milliamperes and beta is equals to 80, where IC is equals to beta into IB plus IC E naught, beta into IB plus IC E naught. So here 2 is equals to 80 into 20 into 10 to the power of minus 6, that is 20 microamperes. Beta into IB, that is 80 into 20 microamperes, 20 into 10 to the power of minus 6 plus IC E naught, where IC E naught is equals to 0.4 milliamperes. Now this is the IC E naught which we got. Now we don't have direct relation with IC E naught and beta. So for that we need to calculate the alpha value. So the alpha value is equals to beta by 1 plus beta, which is equals to 80 by 80 plus 1, that is 0.988. Now ICB naught is equals to 1 minus alpha into ICE naught, that is equals to 1 minus 0.988 into 0.4, which is equals to 0.0048 milliamperes. This is the ICB naught value corresponding to the given transistor. The next problem is, in a transistor circuit, collector load is 4 kilo ohms, whereas the collector current is 1 milliamperes. And first we need to calculate what is the operating point VCE if VCC is equals to 10 volts. And what will be the operating point if RC is equals to 5 kilo ohms. Now let us take the given data. Here RL is equals to 4 kilo ohms and IC is equals to 1 milliamperes. What is the operating point if VCC is equals to 10 volts? So VCE is equals to VCC minus IC into RC. Here 10 minus IC value is 4 kilo ohms into 1 milliamperes. Kilo and milli will get cancelled. So it will become 4 into 1, 4. 10 minus 4, which is equals to 6 volts. So the operating point is 6 volts and 1 milliampere. Now the second case is, what will be the operating point if RC value is 5 kilo ohms? When we change the RC value as 5 kilo ohms, that is VCE is equals to VCC minus ICRC, that is 10 minus 5 into 1, which is equals to 5 volts. So the operating point will be 5 volts and 1 milliamperes. This is the way we need to calculate the several parameters corresponding to the transistor based on the given data. In this session, we have discussed the question bank problems on bipolar junction transistors. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.